All right, hello, welcome back to lesson 103. So yesterday's lesson we did two things, and today we're going to do three things, because when you have two things that don't really go together and put them in a lesson, what is the best thing to do? Well, that's right, get three things and put them together in a lesson, because I guess that makes sense. And so that's what we're going to do today in lesson 103, which is power of negative numbers, dividing terms, and square root of monomials. Yeah. They don't really have to do a lot with each other, but that's what your book put. And this time we're going to do two examples per section. And so I'm going to actually go in order this time because they don't have to do anything with each other. They're a little bit different. And in fact, I think the first part is going to be the easiest part. The other parts I don't think are super complicated if you know how to divide and if you know how to square root things. And so let's jump in to the lesson. Okay, so example one. Example one is just multiply these things together. And so the first section is called powers of negative numbers, but yet we don't have different powers just yet. So I'm going to actually explain that in example two. I know that before example one, they have this huge explanation, but then they give you this example and it's like, what? What are they doing? Well, what they're doing is they're trying to teach you how to do math really quickly with signs first. So I'm going to do math two ways here, or you should be doing math two ways. You first have to do math of the signs. Remember, positive and positive is positive. Remember Mr. Silva's magical table? Yay! So positive and positive is positive. Positive and negative is negative. Negative and positive is negative. And negative is positive. Mr. Silva's magical table, yay. So once you actually remember that, it's pretty easy to do math with signs. That's what we're trying to tell you. So the first thing is do the math with the sign and then do the math with the numbers, which doing the math with the numbers by now should be very comfortable for you guys because we're trying to move you away from the math that you were doing before, just adding, subtracting, multiplying, dividing, and putting new elements that make it a little bit more complicated. Now, I don't think it's super hard yet. And so please realize by now, I expect you to be able to, without the signs, to multiply 3 times 4 times 5 times 2 times 3. It's not that hard, okay? I hope that you can actually do that. And you have to be able to do it. The hard, quote-unquote, part is going to be do the math with the signs, which, again, is not very hard if you remember the table, because positive and positive is positive, okay? So after these two, I multiply these two signs, I get positive. Then I multiply by a negative. Well, positive and negative, according to the table, is negative, okay? So then after this three terms, I have a negative. But then I have negative times negative. Negative times negative is positive. So after this four terms, I end up again in positive. But then I introduce the last term and it's negative. Positive and negative is negative. So my overall answer is going to be, that's right, negative. Then I have to multiply. 3 times 4 is 12. 12 times 5 is 60. 60 times 2 is 120. 120 times 3 is 360. Do I expect you to do it in your head? Yes, I do. It should be negative 360. And you should be able to do this in your head. That's why I didn't show any work, because that is part of the mental math that you're supposed to be able to do. All right. So that's it. Yeah, that's it for example one. All right, so this is example two, and this is where I'm going to explain to you the first part that was there before the first example. The reason I'm going to explain to you is because it has to do with exponents, and now we're talking about exponents for negative numbers. Look, the number I'm raising it to the fourth power is negative 2, and in here I'm raising this number, negative 2, to the fifth power. So there is a difference not only in number but in sign. So to explain it, I'm going to use the easiest number possible, 1, but it has to be negative 1, okay? So if I have negative 1 squared, well, negative 1 squared is going to be negative 1 times negative 1, which, as I told you here in my table, negative and negative is positive, so it will be positive 1. Oh, wow, look at that. And now we have negative 1 cubed, or raised to the third power, which is negative 1 times negative 1 times negative 1, which is going to be negative 1 times negative 1 times negative 1. And so negative 1 times negative 1 is 1, as we already showed. And 1 times negative 1 is going to be negative 1. Okay, what if I raise it to the 4th power? Negative 1 times negative 1 times negative 1 times negative 1. So, negative 1 times negative 1, it's positive 1. And negative 1 times negative 1 is positive 1. And positive 1 times positive 1 is going to be 1. And so their pattern will develop. Do you want to see it? Well, I'm going to show it to you right now. The magic not of editing, but of erasing. Wow, erasers. So, in here we have negative 1 to the 5th, which is going to be negative 1 times negative 1 times negative 1 times negative 1 times negative 1. So negative and negative is positive 1, and negative here is going to be positive 1. So that all is 1 times negative 1 will be negative 1. And so every time I have even exponents, it will be positive. And every time I have odd exponents, it will be negative. And that's what the first part of the lesson was. It was talking to you about what happens when an exponent for a negative number, like what happens to the actual answer. Is it going to be positive? Is it going to be negative? And based on what we were going to do, which is negative 2 raised to the 4th power, well, 4 is even. So I know it's going to be positive. And then all I have to worry about is multiply 2 times 2 times 2 times 2, or 2 4 times, right? Not 2 times 4, but 2 times 2 times 2 times 2. So 2 by itself 4 times. And so 2 times 2 is 4, times 2 is 8, times 2 is 16. It's going to be positive 16. Right? And then in here, the other example was negative 2 to the 5th power, which is negative 2 times negative 2 is, well, actually, let's do the math with the signs first. You see, I was already jumping the gun. Negative number to the 5th power, because it's an odd exponent, is going to be negative. Well, if 2 to the 4th is 16, then 2 to the 5th is going to be 16 times 2, which is 32. And so in here, we're not trying to trick you whether or not you know what 2 to the 4th is or 2 to the 5th is. We're trying to show you that you have to know that if it's an even exponent, it will be positive, and if it's an odd exponent, it will be negative. Odd exponent, it will be negative. And that is it for the first part of the lesson. Okay, example number 3, we're going to divide some terms. Yay! And so the first thing that I'm going to say is, when you first look at it, it looks a little bit overwhelming. And so what I say is, make it as easy as possible. Why don't we just do that? And so the easiest way possible is to divide by terms. So I'm going to divide 4 things. The first thing, the second thing, the third thing, and the fourth thing. I break it down into those components because I think it's actually easier than the other ones, right? Because when I have 12 divided by 3, well, everybody knows that 12 divided by 3 is going to be 4 over 1. That's it. So I already started writing my answer. I already did the first part, which is 4 over 1. I'm not going to put the 1 here yet, and you will see why I don't want to do that. Then in the second part, we have x cubed over x squared. And I have to always remind you of the properties of exponents, that you have x to the a power over x to the b power. The property of exponent is going to say that if we have the same base, different exponent, and it's being divided, we're going to leave the same base and we're going to subtract the numerator, the exponent in the numerator, by the exponent in the denominator, or the exponent in the top by the exponent in the bottom. So it's going to be x a minus b. Well, in here, this is literally where this example helps us a lot. And this is very useful for this particular example. And so we're going to have x cubed and x squared. Well, x cubed is going to be x to the x3 minus 2. And so my second part is going to be x. So I'm going to put an x on the top. Look at that. Beautiful. Then the third part is going to be y over y, which you just cancel out, because what is 4 divided by 4? 4 divided by 4 is 1. 5 divided by 5 is 1. 180 divided by 180 is going to be 1. So y over y is going to be 1, right? And then, you see I jumped the gun with the little line for the answer. And then the fourth one is going to be z squared over 1. Not 0, but 1. Okay? Because anything times 0 is 0, we had to assume there was a 1 here, because 1 times 3x squared y is going to be 3x squared y. And so in here, I'm just left with 4x. That's it. Oh, no. I forgot the z squared. You see, that's why it's important. It's also important not to do math with pen. That's why it's really important to not do math with pen, because everybody makes mistakes. Everybody has those days, okay? So 3xz squared is going to be 4x z squared is going to be the answer to example 3. I got a little bit mixed up because I was going to say example 3 and 4xy squared, 4xz squared, and I made a mistake. All right, but that's it for example number 3. Let's move on to example 4. Okay, example number 4. I rewrote my property of exponent right here, and I wrote a new one here where it means that x to the negative 1 exponent is going to be the reciprocal of x, not of the negative 1, but the reciprocal means the flip of x. What is the flip of x? Well, it's going to be x is x over 1, and the flip is going to be 1 over x. So the negative 1 means that we're going to flip it back here, but if it was negative n, oh, that's a terrible n. Let's just rewrite that in. X to the negative n, then it would be 1 over x to the n. Okay, so it's not that the n is going to be the reciprocal. The negative affects the base, not the exponent. Okay, so in this example right here, we're saying that we have to divide it into 4 parts again. 1, 2, 3, 4 parts again. And so 10 divided by 8, I can actually simplify that by dividing both 10 and 8 by 2, right? So 10 divided by 2 is 5, and 8 divided by 2 is 4. So I'm going to have 5/4. That's my first part, okay? Then I'm going to have to do a cubed over a. So my second part, a cubed over a, I'm going to use that property of exponents right there, which is going to be 3 minus 1, which is going to be a squared. So I'm going to have an a squared in the top. Now in here, I did not jump the gun because I already knew I needed to have my division line or the division bar so that I could put whatever has to be on the numerator and denominator, right? So then my third step is going to be b over b squared. Well, that's going to be b 1 minus 2. 1 minus 2 is going to be b to the negative 1. This is one of the reasons I put this one, right? Because to be able to do the third part, we needed to use the first property of exponent that I put there, and then we had to use the second property of exponents that I put there, and so the b to the negative 1 is the same thing as 1 over b. So I'm going to put the b in the bottom, but I'm not going to put the 1 in here because what is 1 times 5a squared? 1 times 5a squared is going to be 5a squared, okay? And then finally, I'm going to do the fourth one right here. I'm going to do it a little bit here so that I can fit my answer there. So it's going to be c squared over c, which is the same thing as c2 minus 1, which is the same thing as c to the 1, which is just a c on top. And that would be our answer. Our answer for example 4 is 5a squared c over 4b. And that would be it for example 4. Now let's move on to the third part of this lesson, which is square roots of monomials. Okay, and then the last part, square roots of monomials, we need to understand something before we actually jump into the examples. And that thing is what a perfect square is. A perfect square is a number like 121, 144, 169, 196. What do I mean by those numbers? Those numbers actually, if you find the square root, they're going to give you a whole number answer, because square root of 121 is 11, square root of 144 is 12, square root of 169 is going to be 13, and square root of 196 is going to be 14. So all of those are whole number answers. Those are perfect squares, because when we find the square root, we're going to find a whole number answer. Just like 49. Square root of 49 is going to be 7. Okay, so in here what we're supposed to do is factor it out. Okay, but we already know that 49 is 7 times 7, right? So we are going to put 7 times 7. And x is the same thing as x times x. Not to be confused, and I'm going to put it right here, with x plus x, because x plus x is 2x. The coefficient again. What is 1 plus 1? 2. 2x. Now, x times x is going to be x squared, not 2x. Whoops. Almost wrote the same thing. X squared. Different things. Multiplying and adding. Different things altogether. You have to understand that. So, if you understand that, then you know that it would be 7 times 7 times x times x. Why is this important? Because if we find the square root of 49... we're saying what number multiplied by itself gave us 49? Well, it's 7. Okay, then what number multiplied by itself, or what variable multiplied by itself gave us x squared? Well, x squared is going to be x, because that's what it put here. Another interesting way of thinking about it is that if you know that this is squared and this is square root, they're opposites, like adding and subtracting. What is x plus 2 minus 2? Well, plus 2 minus 2 is going to be 0, so it's going to be x. You see, opposites, like the opposite operations. And then what is 2x divided by 2 equals to? Well, the 2 and the 2 cancel out, so it's x. Well, what is square root of x squared? Because they're opposite operations, they cancel out, and it would be x. So that's another way of thinking about it. Now we can actually jump into the actual examples for this lesson. Okay, example number 5. So in example number 5, I have, you just have to actually tell me which one of these is a perfect square. So, rule of thumb, if the number is not a perfect square, it cannot be a perfect square. So 8 is a perfect square? No, it's not. 4 is, because square root of 4 is 2, but 8 is not. Square root of 8 is something that you guys don't know what it is. And so we're not going to go deeper into it. X squared, we know that square root of x squared is going to be x. And square root of y to the 4th is actually going to be y squared. Okay, the reason is because y to the 4th is the same thing as y times y times y times y. So square root of y to the 4th will be the same thing as y squared. Because I multiplied y squared twice to get y to the 4th. That's why square root of y to the 4th is going to be y squared. Okay? So keep that in mind. So this one doesn't count because this one's not a square. The number is not a perfect square. This one is a perfect square. This one is a perfect square, but this one is not, because y is just by itself. Square root of y is just square root of y. We don't know what it would be. But in here, 36 x squared y to the 4th, this one would actually be it, because square root of 36 is 6, square root of x squared is x, and square root of y to the 4th is y squared. Boom. That will be our perfect square for a monomial. Okay, I was just checking whether or not I recorded. I was recording. And so inadvertently, I kind of already answered example 6. And it's pretty easy because square root of 36 is going to be 6. Square root of x squared is going to be x. And square root of y to the 4th, as I already showed you, is going to be y squared. And boom, that is what's going to be the square root of 36 x squared y to the 4th. And the key here is to actually break it into components because we know square root of 36 is 6, square root of x squared is x, and square root of y to the 4th is going to be y squared. And then you just put them together. 6 times x times y to the y squared, and boom, that is our answer. And this is it for lesson 103.